Hello everyone! In this C programming tutorial, we explained how to automatically create linked lists from the user input. Here is the problem formulation. A person enters a series of integers through a program terminal where -1 denotes the end of the input. For example, the input can look like this: 1, -5, 10, 12, and -1. This -1 over here denotes the end of the input. The constructed list is shown to the right, that is, it's shown over here. It should contain the head pointer pointing to the first node in the linked list, and the last node is illustrated over here. Its link is a null link. Write C functions that will automatically create a linked list from the user input. That is, we want to write a C function that will take this input, read this input, and construct this linked list. Then, write a function that will print the entries of the linked list. Then, write a function that will erase all the entries of the linked list. And here's the copyright notice. This video lesson developed code files and documents should not be copied, redistributed, or posted on public or private websites, public or private code repositories, or social media platforms. This lesson and all the provided study materials are strictly for personal use. Without the permission of the author, this lesson and the provided material should not be used for commercial purposes and for training of engineers working in companies. This lesson and the provided material should not be used as lecture materials on online learning platforms and in university courses. This lesson and the provided material should not be used to train an AI algorithm or a large language model. But before I start with explanations, I need to mention the following. If you're completely new to C programming language and to linked list in C programming language, I suggest the following. I suggest that you watch one of my previous tutorials that explains the basics of linked lists and how to implement linked lists in the C programming language. Here is the video tutorial. I will provide a link to this video tutorial in the description below this video. Let's start with coding. First of all, to edit C files, I'm using Visual Studio Code. Then, to compile C files, I'm using GCC compiler. Let's start. I'm going to start Visual Studio Code by just opening a terminal, navigating to my base folder and typing code dot. And let's create a new file. Click on File, click on New File, and let's call the file linked list1.c. And let's save the file. The first step is to include the necessary header files. First of all, let's include stdio.h, since we will be printing something and we will read integers from the terminal. Then we also need this header file, stdlib.h. This header file is necessary for using the malloc function. Over here, we declare our node. In my previous tutorial, whose link is given in the description below, I explained that usually in the C programming language, nodes are implemented as C structures. Consequently, we will follow this strategy. So let's declare a struct called node, and over here, let's declare the entries. We will have the integer, which I will call store data. We will use this integer to store the number that the user enters, and then we will have this pointer to struct node, and I will call this pointer simply as link. This pointer will be used to link other nodes in our linked list. Here is the first step that we need to perform. We need to declare and define a function that will accept an integer value that is read from the terminal and the pointer to the head of the existing linked list. By using this information, the function should: number 1, create new node, fill in the stored data variable of the new node with the provided integer. Number 3, link the new node to the top of the linked list. And number 4, return a pointer to the newly created node that is linked to the linked list and that is at the top of the linked list. This new pointer is the new head of the list. Let's start with implementation. Over here, let's add a comment function that adds a new node to the list. The function should return a pointer to the new node that is at the same time linked to the list and it is at the top of the linked list. This pointer is actually the new head of the linked list. Consequently, the function should return a pointer to struct node, and I will call the function as addNode. The first input parameter is the pointer to the head of the existing list. I will call this pointer pHeadNode, and the second input parameter is the provided number. This provided number should be read by some other function or in the main function from the user input. First of all, let's declare a pointer that will store a pointer to the newly created node. I will call this pointer pNewNode, and we will return this pointer. Okay, over here, let's use the malloc function to reserve the memory space for the new node and to create the new node. To do that, we need to do this. We need to call the malloc function and we need to use the operator sizeOf. The input of the operator sizeOf is our data structure, struct node. Consequently, over here you need to type sizeOf struct node. The malloc function will reserve the memory space for the new node and it will return a memory address at the beginning of this reserved memory space. That is, it will return a pointer to the reserved memory space, or better to say, to the first address of the memory space. Let's store this pointer inside of our pNode. Now pNewNode will point to the memory address that will be used to store the new node. Now, it's always a good idea to implement these guards, since sometimes the malloc function can return a null pointer. A null pointer is returned if malloc function was not able to reserve the memory space. So let's type if pNewNode is equal to null pointer, then we need to print the message. And the message over here will be printf could not allocate the memory for the node. And let's end the line, and over here I will exit my program by simply typing exit and by providing this constant exit failure. If you want to know more about exit failure, you can simply double click over here and type go to definition, and you will see that exit failure is actually 1. Exit success is 0. So let's close this stdlib library in order not to blur the main ideas with too many C implementation details. Now, over here, we need to fill in the entry of our new node. That is, we need to fill in the variable stored data. Consequently, we need to type this pNewNode, then we use this operator to access store data, and we need to simply type number. In this way, we will store the number inside of the stored data. And here comes a very important step. Now we need to link this new node to our existing linked list. And for that purpose, let's go back to the slides, and over here I explain the process of linking the new node. Here is our existing linked list. This p head node is a pointer that's being passed to our function as the input parameter. This pointer points to the head of the existing linked list, that is, it points to the first node inside of our linked list. Over here, by using the function malloc and by assigning the data storage to be equal to the number, we actually created the new node and we filled in the data entry. The next step is to link this new node to our existing linked list. So how do we do it? Well, we do it like this. We set the link of our new node to point to the same node that p head node points to. That is, this link should point to the first node in the existing linked list. And after we do that, we will obtain this graph over here. We will place our new node at the top of the linked list by simply saying that this link over here of our new node should point to the first node of the existing linked list. After this operation, p head node will still point to this node, that is, to the previous first node inside of our linked list, and we are going to return this pointer. That is, the function will return this pointer. Later on, we will adjust this node over here, actually this pointer over here, that is the p head node, such that it points to the top of the linked list. And we will do that outside of the function. That is, our function will perform this step, it will create a new node, and it will fill in the entry of this new node, and it will link this new node to the existing linked list. And outside of the function, we will do this. Over here, we need to link our new node to the top of the existing linked list. To do that, we simply need to type p new node, then we need to access the link, and this link should be equal to p head node. By executing this statement or this code line, our link will now point to the same memory address that p head node points to. That is, it will point to the top of the existing linked list. That is, to the first node of the existing linked list. And after we perform this step, we just need to return p new node. Now the p new node points to the top of the updated linked list. And outside of this function, we need to adjust this p head node. In the step number 2, we need to declare and define a function that will create a linked list. The function should, number 1, create a head node and set it to null. Number 2, read the integer number from a terminal in a while loop until -1 indicator is detected. In every iteration of the while loop, the function should call the function add node to create a new node. The first input parameter is the head pointer, and the second input parameter is the integer read from the user input. Then, the function should update the head pointer on the basis of the returned value of add node function such that the head pointer points at the top of the list. And number 4, the function should return a pointer to the head of the newly created list. Next, let's implement this function. First of all, let's add this comment function that will create a linked list on the basis of the user input. Okay. First of all, the function should return a pointer to the head of the list. Consequently, we need to specify the return type, it's struct node pointer, and let's call the function as createList. Over here, we are not planning to pass anything to the function. Consequently, we will have void as an input parameter. First of all, let's declare and initialize our null head pointer. So let's type struct node p head node is equal to null. Then let's declare an integer that will store the number read from the terminal. Then let's print this message, enter integers to fill in the linked list. And over here, let's add a new line to our output stream, and let's print this message, printf, enter -1 to complete the input. And let's again add a new line, and let's not forget the semicolon. Next, let's implement a while loop that will read the input. Consequently, I will type while 1, and over here, let's type this. To read the input, we need to type scanf, and over here, we need to use the format specifier. We need to use %d since we plan to read integers. Then we have a comma, and then over here, we need to type this number. That is, we will store the number read from the terminal inside of this number over here. Then we need to check if the number is equal to -1. If that's the case, then we just need to return our p head node. So let's type here return p head node. Let's analyze what's written over here, and let's consider the worst case scenario. First of all, let's assume that over here the user just enters -1. So what will happen? This while loop will start. Then here we will read -1. -1 will be detected, and we're simply going to return p head node, which is currently null. Null denotes the fact that this is an empty list. And later on in the main function, we are going to implement an if statement that will check if p head pointer or any pointer returned by this function is null. This means that the list is actually empty. Okay, so this works as expected. Now, what happens if a user enters, for example, 2, 3, and -1? Okay, over here, we are going to first of all read 2 and store it inside of our number. This means that over here, we need to create a few things. First of all, let's declare a struct node pointer, and let's call this pointer p new node, and let's set it to null. Then after that, let's type this p new node is equal to add node. That is, over here we are calling the function add node. The add node needs to accept as a first input parameter the head of the current linked list, and the second input parameter is the actual number. Consequently, over here, let's type add node, and let's pass p head node as the first input parameter, and the second input parameter should be the number we just read. This function will create a new node and it will link this new node to the top of our linked list. And it will return the pointer to the new top of the linked list, and this new pointer will be stored inside of this pointer. However, the issue over here is that we are not going to return pNewNode. That is, this function will not return pNewNode, it's going to return pHeadNode. And consequently, over here, we need to update the pHeadNode such that the pHeadNode points to the new top of the linked list. And we do it like this, simple as that. Instead of writing these two lines, you can simply type this. I will leave it in comments such that you know what I will type. You can simply type this. pHeadNode is equal to addNode pHeadNode, number. However, I don't like these type of statements since they might look confusing. And that's it. This is the implementation of the function createList. Let's now perform a test. And let's see. This is our user input. Over here, number 2 is red. It's stored in the number. This if statement is not being executed since number is not equal to -1. Then we go over here. We create pNewNode pointer, set it to null. Then we call the function. We pass the pHeadNode. pHeadNode is currently a null pointer, and we pass the number 2. Then inside, let's go to the addNode function. pHeadNode is currently a null pointer and number is 2. Over here we declare a new pNewNode pointer. We allocate the memory space for the new node. We check if the memory allocation was performed successfully. Let's assume it is. Then what do we do over here? We set the store data to be equal to 2. And then we say that a link of our new node is simply equal to null. This means that this new node is actually the end of the linked list, since a node that has a link that's equal to null is actually the end of the linked list. That is, we placed number 2 at the bottom of the linked list. And over here we return a pointer to this newly created node. Then what do? We return over here. We store this pointer inside of our pNewNode. And note over here that this pNewNode is a completely different variable from this pNewNode. This is mainly because these are the two different functions. Then what do? Currently pHeadNode is still a null pointer. However, we need to update pHeadNode, and we simply say pHeadNode is equal to pNewNode. Now pHeadNode points to the top of the linked list. That is, it points to the node that stores 2. Good. What happens next? User enters 3. Then what happens? We read number 3. This part is not executed, and then we repeat the procedure. We send to add a new node the updated pHeadNode pointer, and we send number 3. This function will create a new node, store number 3, and return a pointer to that new node. Then we will simply update the head. Now head points to the node that contains number 3. Then over here, -1 is read, and this part is being executed. We simply return the pointer to the head of our linked list. That is, we return the pointer to the node that contains 3. However, that node is also linked to the node containing 2, and that's the whole story. Now, note over here that we don't return a value nowhere inside of the main body, that is somewhere over here, of our function. we actually performed the return statement over here. What is the effect of this? The effect of this, that this while loop will be infinitely executed until -1 is detected. I selected this solution, however this solution might not be robust. Namely, this while loop in certain cases might be infinitely executed and your program might never complete. However, over here, I assume that the user will always be careful when entering numbers. That is, he or she will always end the input with -1. In practice, if you want to make this code more robust, you have to worry about the fact that the user can enter here characters, floats, or there might be some input errors. And you need to implement a guard that will prevent this while loop from executing infinitely. For example, over here you can add an additional condition. If a certain number of entries is being read, then stop the input, do not increase the list, and simply return the head pointer. Next, we need to declare and define a function that will print the data stored in the nodes of our linked list. Let's add a comment. Function for printing the data stored in nodes of a linked list. Since this is a printing function, the return type is void. That is, we will not return anything. I will call the function as printList. The only input parameter is a pointer to the head of the linked list, and I will call this pointer pHeadNode. If pHeadNode is equal to null, this means that we have an empty linked list. Consequently, let's type if pHeadNode is equal to the null, then we will print the message. Printf, the linked list is empty, and then new line. And don't forget the semicolon. Otherwise, let's print the data stored in the nodes of our linked list. So here's the main idea. We need to define a special pointer that will serve as an iterator. This pointer will iterate through the nodes of the linked list. It will start from the first node, then it will follow the link to go to the second node, third node, fourth node, fifth node, until the end of the linked list. The end of the linked list is simply denoted by the null pointer. That is, when a link of a node becomes a null pointer, this means that we have reached the end of the linked list. And we can use this condition to stop the iteration. In every iteration, we will simply print the value stored in the node of the linked list. First of all, let's declare a counter. I will call this counter simply as counter, and I will initialize its value to 1. Then, let's declare an iterator pointer. I will call this pointer as pCurrent, and I will set this pointer to be equal to the pHeadNode. That is, initially, pCurrent will point to the top of the linked list, that is, to the first node inside of our linked list. Now, let's type this, while pCurrent is not equal to null, that is, while we didn't reach the end of the linked list, we need to print the values. To print the values, we simply need to type printf, the value stored in the node, let's use this format specifier for the integer, is %d, again another format specifier, and then first we will print the counter, which is initialized with 1, and then we will simply do this. We will type p current then we will use this operator to access the member variables. We need to access the stored data, and that's it. And let's end this line. So let's see again. Let me move this. The value stored in the node counter is pcurrent stored data. Simple as that. Then what do we need to do? We need to increment the counter. And then after that, we need to step further down our linked list. So we need to update the pcurrent. Pcurrent is equal to the current node, which is again pcurrent, and then we need to get its link. This statement will update pcurrent such that it points to the next node inside of our linked list. And that's it. Simple as that. And that's it. This is our print list function. Let's now nicely organize this function. And again, over here, I assume that everything is perfect. That is, that the list is ended with a null pointer and that everything is done like a Boy Scout will do. That is in a disciplined way. However, if you want to make this program more robust, you will have to implement several guards over here. Namely, a list sometimes might not end with a null, and you might experience an infinite while loop over here. However, I leave this to you to improve this code. The next step is to declare and define a function that will delete the list. Why do we need to delete the list? Let's go all the way up and let's analyze this function for adding the node. Note over here that we are using the malloc function to reserve memory space. Namely, if you would now execute this code, namely, if you call create list, you read the input, then you call this function many times, in every iteration, memory space will be reserved. However, the program will stop, then all the pointers will be gone. However, the memory space will still be reserved after you finish with your program. And that fact might create a memory leak. Over here, if you're entering 100 or 1,000 numbers, there will be no issues. However, if you're entering 1 billion numbers, and if you have small memory, this might create a serious memory leak. Consequently, whenever you use the malloc function, it is suggested to delete the memory space. That is to free the memory space. And for that purpose, we need to declare and define delete list function. Delete list function will return a void. That is, it will not return anything. And let's call this function as delete list. Again, the only input parameter is a pointer to the head, or actually the head pointer, pHead node. And again, how to delete the complete linked list. The idea again is similar to the idea for printing the linked list. We will iterate through the linked list until we reach the end of the linked list. The end of the linked list is denoted by the null link. In every iteration, we are going to erase the node, and then we are going to simply move the head pointer down the linked list. But again, let's check if the list is already empty. That is, if pHead node is equal to the null pointer. If that's the case, then we need to printf. Over here, we need to printf the provided list is empty. No need to delete. And then let's start a new line. Here again, we need to declare an iterator pointer. So let's type struct node p current, and let's initialize with this pointer with the head. That's it. Over here, we need to write our while loop that will iterate through our linked list, and over here the condition is p head node not equal to null. Why I'm writing this? I'm writing this because I'm going to iteratively update the head pointer, and the head pointer will go down the linked list. Once it reaches the linked list, that is, once it reaches the end of the linked list, to be more precise, it's going to become null. This means that we have completely erased our linked list. So let's write over here, p head node should be equal to p current link. What do we do over here? We set the head pointer to point to one layer below its previous value. That is, it's going to point to the node that's down the link. For example, if the p head node at the beginning is pointing to the first node, after this statement, it's going to be pointing to the second node. Why do we do that? Well, we are doing that since we want to erase the first node. And the pointer to the first node is not lost, it's being stored over here. So now, to erase the first node, we simply need to type p free p current. And that's it. Over here, we erased the current node, that is, we erased the first node. However, we step down the linked list. Now p head node points to the second node. And let's print the message. Node. Let's specify over here one very important thing, node number. To specify the node number, we need to use this format specifier. However, over here, we need to declare a counter. So let's set this counter to 1. Okay, and over here, let's type node, format specifier for the integer, destroyed, and memory freed. And let's print the counter. Then over here, let's not forget to start a new line. Then let's update the counter. After updating the counter, we need to do the following. We need to set p current to be equal to the new p head node, such that in the next iteration of this while loop, we can again do this. And that's it. That's our delete list function. And finally, let's write our int main function. Let's return 0 over here, and let's type struct node pointer head. Over here, we declare an empty head pointer. Then we write head create list. What do we do over here? We call the function create list. Let's go to this function. This function will read the user entry, and it will create a linked list, and it will return a pointer to the first node of the linked list. We store this pointer inside of our head pointer. After we do that, we simply type print list, and we simply pass the head pointer, and then finally we type delete list head. And that's it. Simple as that. That's our main function. Let's save this code, and the next step is to compile and to run this code. Let's go back to the terminal and let's see the structure of our folder. Here's the source file. In this video tutorial, I'm using GCC compiler to compile C files, and consequently I need to type this. GCC will call the GCC compiler, W all and W will make sure that all the compiler warnings, or better to say most of the compiler warnings, are displayed, and this option O means that I want to specify the output file name of my executable file. I will call it as linked list 1. I will use the same name as the name of my source file, and then over here as the last input parameter I need to specify the file name of my source code. So let's press enter and let's see what will happen. No compilation warnings or errors. Let's see again the structure of our folder and the content, and here's our executable file. So let's start with tests. So let's start linked list 1, bang. Now over here you can see what happens. You will see this window Avast Cyber Capture. In your case you might not see this window unless you're using an Avast antivirus. In my case I'm using Avast antivirus, and for some reason Avast always keeps an eye on the programs that are running on my computer. I'm going to simply close this terminal and the program will be back. Enter integers to fill in the linked list. Okay, so let's go back and let's see where we are. This statement is executed. Now we call the function createList, and let's see where we are. Currently we are here. The user needs to enter the input and the end should be -1. Let's start with the extreme case. Let's just specify -1 and bang. Since -1 is given, this function will return a null pointer. Then print list will check if the pointer is null. It is. That's why you see this output. The linked list is empty. And then again delete list will again type the provided list is empty, no need to delete it. Perfect. Works as expected. So let's now execute again and let's do this. 5, 6, -1. Bang. Let's see. This is the input. And we can see that we were able to return something from our function, that is from the function createList. We can see that the print list is being called. And let's analyze the output. Over here, since we entered 3 numbers and we don't count the last number, we will have 2 nodes. And that's precisely what's written over here. There are 2 outputs, which means there are 2 nodes. And the value stored in the node 1 is 6. This is excellent, since 6 is the last number that's being read and it's being placed at the top of the linked list, and that's the node 1. Then over here we can see that the value stored in the node 2 is 5, and that's precisely the value. And over here we can see that the delete function is saying node 1 destroyed and memory freed, and node 2 destroyed and memory freed. So let's run this again and let's put many numbers. Let's see, whatever we want, since these are the integers. And let's do this. And bang, here it is. Let's count the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we can see 11 prints here from the last one to the first one, and everything is being freed. Works like a charm. Now, of course, you can try to create an input that might confuse our program. So let's try to do that. Let's start first with floats. For example, you might try to enter -5.2, then let's enter an integer, and let's enter something like this, and let's try to enter a character, for example, and another character and -1, and let's see what happens. And you see there's an issue. Now everything is being run, and I need to press Ctrl+C, and I probably have created a memory leak over here. And that's why here there is a significant issue. Now, be careful what you're doing over here. Do not provide these inputs, since these inputs might crash your system. Right now, I created significant memory leaks, and probably I will need to restart my computer. Consequently, when you use this program, be very careful to correctly format the inputs. Okay, that's all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons, and see you in the next video tutorial.